Hello students, now we are learning about the new reaction, that is a Kolbe reaction, which is there in your syllabus under the electrophilic substitution on aromatic ring. So let's start with the Kolbe reaction. Kolbe reaction is a reaction for the synthesis of phenolic acids. What will happen in the Kolbe reaction? There is a treatment of salt of phenol with carbon dioxide brings the substitution of carboxyl group that is COH instead of hydrogen on benzene ring. This is the Kolbe reaction. The most important application of this Kolbe reaction is conversion of phenol itself into orthohydroxybenzoic acid, which is also known as salicylic acid. Okay, what it is? Synthesis of phenolic acids. It is a Kolbe reaction where the treatment of salt of phenol and carbon dioxide takes place, causes substitution of carboxyl group, that is COH, for hydrogen on benzene ring. The most important application of this reaction is conversion of phenol itself into the orthohydroxybenzoic acid. So let's see the general reaction of this Kolbe synthesis, that is phenolic acid synthesis. This is a phenol react in presence of base, that is NaOH. What will happen? This phenol, when it is react with the strong base, there is a formation of phenolic salt, ONA. Okay, this is called as sodium salt of phenol. This phenoxy group is very important over here. When it is react in presence of carbon dioxide at 125 degrees Celsius, first there will be formation of Na, and here is OH. How it will form, that we will see in the mechanism part. Sodium salicylate, which is the chief product. Then protonation, or you can say the electrophilic attack takes place. Here is formation of acid known as salicylic acid. Okay, so here there is a formation of salicylic acid takes place. So this is a general reaction of Kolbe synthesis. Now let's see the mechanism of this reaction. Let's start the mechanism. Okay, now first step is same, that is formation of phenoxy ion or sodium salt of phenol. Let's form the sodium salt of phenol. Here what will happen, in presence of NaOH there will be formation of O minus, sorry, here is a phenol Na. Okay, now what will happen over here, the sodium salt of phenol which is formed over here, in second step it will be reacted with your carbon dioxide, oxygen, now we will show this phenoxy salt, that is with its sodium salt minus charge and your carbon dioxide. Now what will happen over here, this carbon dioxide will form first carbocation by shifting this double bond. This oxygen take this electron. So what will happen, now there will be a formation of bond between this carbon and this benzene ring. So what will happen, this sodium will get removed. Now this carbon become deficient one, so oxygen share its electron with this carbon. Okay, now what will happen, there will be formation of product like this. Oxygen with lone pair of electron. Here there is a hydrogen, sodium and here this product. Okay, now what will happen, this is again get shifted over here, so this hydrogen give its electron to this benzene ring. This hydrogen will get removed or taken by this sodium, Now what will happen? So this hydrogen which is taken by this sodium is get now form a bond with oxygen. There is a formation of OH, COO minus, and your sodium ion. Okay. In second step, what will happen? Sorry, in third step, what will happen? This is unstable in nature. Okay. So, what will happen over here? This, to stabilize this one, I will draw again this product here. C double bond O, O minus, protonation takes place, and in protonation there will be formation of OH, COOH, that is orthohydroxy benzoic acid, that is also known as your salicylic acid. So this is a mechanism behind the formation of phenolic acid, which is known as a salicylic acid from its phenol salt. Okay, let's again revise this Kolbe reaction. In this reaction, synthesis of phenolic acid takes place, in which treatment of salt of phenol plus carbon dioxide will react with each other. Substitution of carboxyl group takes place instead of hydrogen on benzene ring. Conversion of phenol itself into the orthohydroxy benzoic acid. It is a product of your Kolbe reaction, which is also called as salicylic acid. The general reaction of this Kolbe synthesis is this phenol in this case, in presence of strong base, this will form a sodium salt of phenol. In presence of carbon dioxide at a temperature of 125 degrees Celsius, it will form a sodium salicylate, which after electrophilic attack, that is in presence of hydrogen, what will happen? Formation of salicylic acid. The mechanism of this reaction is, in this mechanism, first step is the formation of phenoxy ion, or you can say sodium salt of phenol. Your phenol, in presence of NaOH, there will be formation of sodium salt of phenol. The phenoxy group is a main role in this reaction. It is formed by the carbon in between the double bond of carbon and oxygen will get shifted on oxygen. So, it become carbocation. This carbocation is take an electron from this benzene ring. So, to stabilize this carbon, the oxygen share its electron and it break a bond with sodium. So, there will be sodium as it is in the solution, and the hydrogen which is there, after formation of bond with this carbonyl carbon, the hydrogen will be dragged by the sodium from here. So, this electron will get shifted in the benzene ring to stabilize this carbon, and the oxygen take its electron towards itself. Now, the oxygen become O negative. To stabilize this, the hydrogen will form a bond here with oxygen, which is unstable in nature. Now, the carbonyl the carbanion which is this form, the negative ion which is formed over here, which is stabilized by electrophilic attack of hydrogen, this protonation takes place and there will be formation of orthohydroxybenzoic acid, which is also called as salicylic acid. So, here we will finish with the reaction Kolbe synthesis. Now, let us start with the last reaction from your syllabus, that is Reimer Tiemann reaction, that is also synthesis for the phenolic aldehyde. Now, let us start with the next reaction, that is a Reimer Tiemann reaction. This Reimer Tiemann reaction is mainly for the synthesis of phenolic aldehyde. Kolbe reaction is for synthesis of phenolic acid and Reimer Tiemann reaction is for the synthesis of phenolic aldehyde. In this Reimer Tiemann reaction, what will happen? The treatment of phenol with chloroform takes place in presence of aqueous OH to give you introduces of aldehyde group, that is C double bond OH on aromatic ring. Generally at ortho position. This reaction is known as Reimer Tiemann reaction. So, let us draw the general reaction where phenol is react in presence of chloroform CHCl3 and aqueous NaOH, that is alkaline solution at 70 degrees Celsius. You will get formation of phenoxy group and your CHCl2 group will be attacked over here. Now, what will happen? The CHCl2 is get converted into aldehyde. And in presence of HCl, there will be formation of phenolic aldehyde, which is called as salicylaldehyde. Okay. The benzyl chloride, which is initially formed, it is hydrolyzed by alkyl reaction medium. Okay. And then you will get the aldehyde group formation over there. The electrophilic substitution on highly reactive phenoxide ion or phenoxide ring. Now, let us start with its mechanism part. Mechanism of Reimer Tiemann reaction. In first step, there is a formation of carbene from chloroform. So let's draw the structure of chloroform. This is a base. What will happen? This base taken out this hydrogen from chloroform. This hydrogen is get removed. It is combined with this OH. So there will be removal of water and formation of carbanion. Okay. Next step, what will happen? Removal of chlorine will take place. So there is a formation of carbene atom. Okay. In second step, what will happen? Your phenol it's come under reaction. The base which is there is help to remove this hydrogen. This deprotonation takes place. The bond which is there in between oxygen and hydrogen will get shifted on the oxygen. Removal of H2O and formation of phenoxy ion. Now what will happen? Due to this formation of phenoxy ion, this double bond is get shifted over here to stabilize this oxygen atom. Now while shifting this double bond over here, this carbon become carbon plus. So what will happen? This bond which is there is get removed out. And there will be formation of this product. Double bond O, hydrogen, hydrogen. Now your carbene will come over here and take part in the reaction. Now what will happen? This hydrogen is taken out by this carbon. And what will happen? The electron which is there over here, it will form a bond with this benzene ring. Okay. After this formation of bond with this hydrogen, this bond will get break down and it stabilize the benzene ring. In this stabilization, what will happen? This double bond again get shifted on the oxygen. So let's draw oxygen become O minus again. Again benzene is get aromatized. Carbon, hydrogen, chlorine and chlorine. Now the chlorine which is there over here, is get removed out. Now this carbocation which is get formed is stabilized by this taking electron from benzene ring, and then there will be formation of this product. How this double bond is get formed? By shifting of this electron over here. Now what will happen? the group, your alkyl group with alkaline group which is there, it helps to form a bond with carbon atom so that it stabilizes the benzene ring. So this bond again taken by this oxygen, this bond is shifted, so this carbon become carbocation, so it form a bond with this hydroxyl group, and you will get a product like this. Oxygen minus carbon, chlorine, your hydrogen, and a formation of bond with OH. Okay, now what will happen? Chlorine group is get removed, again carbon become carbocation, so shifting of this bond to stabilize for aromaticity, this oxygen give its electron. Now what will happen? Again get formation of double bond O, here double bond CH, removal of chlorine, so it will become OH. Okay, now what will happen? The base which is there in the reaction, this is a base, is taken this hydrogen, so this bond is get shifted on the oxygen, this hydrogen will get removed. Now what will happen? The shifting of bond over here will form a electron, lone pair of electron, and this lone pair of electron which is get formed over here, so there will be formation of this compound. Oxygen this bond is get shifted in the benzene ring, so it will get shifted over here, formation of minus charge, this will become double bond O and H because of this shifting of electron in between this. Now what will happen? After formation of this is unstable in nature, so it gives its electron to benzene ring, and there will be formation of phenol. Now here only I will try to draw this structure. Here phenol, and here CH, that is formation of salicylaldehyde. So here your mechanism is finished. I will again explain the mechanism. In first step, formation of carbene ion. How? From chloroform, your base is taken this hydrogen, so this bond is get shifted on the carbon, there is a removal of water, formation of carbanion. After removal of chlorine, there is a formation of carbene. In second step, the phenol, the hydrogen deprotonation takes place in presence of this hydroxyl group, removal of water, so formation of phenoxy ion. This phenoxy ion which is formed over here, this double bond is get shifted to stabilize this oxygen, So it will become this. Now this at benzene, that is benzenone, is react with this carbene. When it is react with the carbene, this hydrogen is taken by this carbon, so this bond is get shifted over here, and this double bond is get shifted on the oxygen. This next 2 lone pair of electron is taken by this carbon to stabilize itself, and now you will get this intermediate. But again this oxygen become unstable, this chlorine group is get removed, so this carbon become carbocation, is taken its electron from this benzene, so oxygen gave its electron to benzene, and it will form again this type of intermediate. So this double bond, now this benzene ring is unstable, so its double bond is get shifted over here, so carbon become carbocation, so it will react with the base hydroxyl group. There is a formation of bond between hydroxyl group and carbon, so at the same time this oxygen taken its electron. Now in next reaction, what will happen after this intermediate formation, this carbon leave this chlorine group, so carbon become carbocation again. To stabilize this oxygen, its oxygen give its electron to benzene ring, this double pi bond is taken by this carbon, formation of again double bond. Now again what will happen, the base which is there in the reaction is taken this hydrogen, and oxygen become O negative, so it give its electron to carbon, this double bond is get shifted over here, and this double bond is get shifted on the oxygen, so oxygen become O negative again. Now what will happen, the protonation takes place, okay, and this O minus become OH, and there will be formation of salicylaldehyde. Okay, so this is your product salicylaldehyde, and here we are finished with the mechanism of Reimer Tiemann reaction. Thank you students, thank you so much.